Thank you, everyone. I'm Stephen Downs. It's a pleasure to be speaking to you in India from my home here in Moncton, New Brunswick, Canada. We had a light dusting of snow overnight, so it's all white outside. And the temperature is a nice warm -1 degree today. So I bring you happy face greetings. Today I'm going to talk on the topic of developing personal learning. And when I talk about developing personal learning, I'm talking about two separate things. On the one hand, I'm talking about the idea, the pedagogical approach of developing personal learning, where what we're trying to do is work with individual students in order to encourage them and help them develop the capacity to learn on their own. On the other hand, I'm also talking about our research program at the National Research Council of Canada, where I work and have worked for the last 13 years. It's a bit scary to say that. On various projects over the years leading toward our current work, which is called Learning and Performance Support Systems, which develops a personal learning environment or the set of tools and systems necessary in order to support personal learning. Might as well begin with one of the things that's been on everyone's minds recently, and that's the MOOC Revolution, and this is a diagram from Michael Feldstein. As was mentioned in the introduction, George Siemens and I developed the first MOOC. It was called Connectivism and Connective Knowledge. And it began in 2008. And over the years since then, we've run a half a dozen to a dozen different MOOCs on different topics. The MOOCs that have become more famous recently began in 2011 with the Stanford AI course, which attracted hundreds of thousands of participants. And this bloomed into three separate systems: Udacity, Coursera, and edX, as commercial, or I guess in the case of edX, less commercial, online MOOC platforms. But the two approaches are very different, and Michael Feldstein quite appropriately puts them in different colors here. The orange represents the connectivist branch of MOOCs, which is based on community and connection and interaction and participation. And the blue represents the Stanford branch, or as I sometimes call them, X-MOOCs, which are based on videos, presentations, quizzes, and tests. In other words, they're much more traditional. The connectivist design, which is what George and I developed, is based on connectivism, which is the learning theory that we developed. George came up with the name back in 2004. Before then, I was calling it the theory of learning networks. And the idea is that it's a non-curricular based approach. And what that means is we don't focus on the content. The content is not something that you are supposed to remember and then repeat back. We think of the content as what we call the MacGuffin. The MacGuffin is a term from the movie industry, and it's the object around which the plot revolves. The MacGuffin is the thing in a movie that everybody's chasing, or everybody's looking for, or everybody's fighting over. And it can be anything. It can be a Maltese falcon. It can be a treasure of the Sierra Madre. It can be the Lost Ark. It can be anything. And that's what content is to us. It's the thing that draws people together and gets them talking. It's a lot like this presentation. In this presentation, I'm giving you content. The purpose of my content that I'm giving you is not to get you to remember it, because you won't, but it's to stimulate your own thoughts and your own interactions after the talk. So you should talk among yourselves, maybe today, maybe in the future, about this talk. And that would be the appropriate way to respond to this talk, rather than trying to remember all the content. Why do we take this approach? Why do we teach in this way? Well, one of the things that we understood fairly early on is that people have different objectives, different reasons for taking a course, different goals, different preferences, interest in different topics or subtopics in the course. There is no one body of content that is going to work for everyone. And it's also a recognition that people's understanding and their knowledge actually varies depending on their perspective and their point of view. We can both look at the same thing and see two different things depending on our background and experience. And both perspectives are equally valid. This is not relativism. It's the recognition that if you look at the same object from two different perspectives, you're going to see it in two different ways. And that's why networks or communities are so important. We can't reach an understanding of that object without communicating between those two different perspectives. You describe what you've seen, I describe what I've seen. We each discuss the relative advantages and disadvantages of our perspective. And together, we learn something new about whatever it is that we're looking at. So let's take a look at the history now, the development of personal learning that I referred to. I wrote a paper in 2008 called The Future of Online Learning, and I still use it as a case study counterexample to those who say that you can't predict the future. In 1998, I predicted things like high-speed wireless internet access. I talked about how important audio and video would be, and synchronous conferencing, just like what we're doing here today. I predicted the iPad in 1998. I even got the name right. Learning objects, I called them modules, learning management systems. And what I always thought was the destination for learning, even back then, was personalized education, or as I would say it today, personal learning. We might ask, how do we predict the future? Because people represent this as some sort of mysterious art. I don't really think it's that mysterious or that difficult to predict the future. In fact, I think we predict the future all the time. I think it's one of the bases of learning and developing personal learning is understanding how we predict the future. I have a talk called Things You Really Need to Learn, and one of the major elements in that is predicting consequences, understanding patterns. And the way we predict the future is the same way we understand the past. We, if you will, read the signs. The history of philosophy is a history of attempting to derive some sort of formal principle for predicting the future, a deductive theory of induction or an inductive theory of deduction, the hypothetical deductive method, the deductive nomenological method, and other theories. But the way we predict the future is actually much less formal than that. We see the signs, we see patterns and regularities and events in the world, and we recognize that, oh, this is one of those kinds of things. This is also how we learn in general. This is also how we understand the world in general. You'll read, perhaps, a lot of theory about how we form complex cognitive models or representations of the world generally built in terms of statements and principles and axioms, and how we codify knowledge, and in that codified form of knowledge make predictions or make hypotheses or general statements or principles about the world. But in fact, we understand the world much more simply. We recognize things. The way we understand, the way we form knowledge is exactly the same way we recognize our mother coming out of the train station or our children walking down the street. We don't run through some sort of inferential principle. We look at them and we recognize immediate direct perception who they are. And it's understanding this, understanding that knowledge is a form of recognition. It's a way of reading based on direct perception that informs the theory of connectivism. Okay. So learning as a form of recognition is something we do naturally. It's something that we've done from the day we were born. Before we knew language, before we could read or write, we were recognizing. We were recognizing word patterns. We were recognizing our mother's faces. We were recognizing food. And it's the sort of thing that from that simple, humble beginning grows into a complex set of basic literacies, including pattern recognition, including critical thinking, action behavior, and all of the rest. And what happens is, as we recognize, we form patterns of recognition in our mind. These patterns layer over each other and become more and more complex, more and more subtle, more and more nuanced. So learning, personal learning, is about developing these recognition capacities. It's about learning how to see the world. In other words, learning is not a matter of remembering. Learning is not an accumulation of facts. Learning is a matter of personal growth. It's a matter of putting ourselves into the experience and practicing and reflecting within that experience. This picture here is a little girl from Armenia who has inserted herself into the environment. If you look closely, you see a digital camera over her shoulder, and what she's doing is she's experiencing the world by putting herself into a position to have a unique perspective on that world and then taking photographs of it. She's growing and developing her own personal capacities in doing that. This learning process is interactive. Again, it's based on perceptions, it's based on perspective and point of view, and therefore is based on interaction with other people with other perspectives. I have a 4-step model. It's a very simple model. You don't need to follow that model. It's just, it could be any of a dozen models, but this one works for me. Aggregate, remix, repurpose, feed forward. The idea is we bring in our experiences, we mix one experience with another experience, one perception, one idea with another idea. We repurpose it, we reshape it to our own needs, and then we share it with our friends and with our community. And this learning process underlies what I call the Downs theory of education, which is not unique to me. This theory is older than civilization, and it's too simple really to be called a theory, but I like calling it the Downs theory. And the theory is to teach is to model and demonstrate. In other words, to create a perspective that people can look at. To learn is to practice and reflect, to work with that perspective and then share that perspective with others. At the National Research Council, this approach, or something very much like this approach, because it's developed over the years, as our understanding has developed over the years, is the basis for the work that we've done for the last 13 years. In 1999, we were working on, or I was working on learning communities. That's before I joined NRC. I built a learning community for the University of Alberta called MuniMall, which was a learning information and resources portal for the municipal community in Alberta, consisting of elected officials and municipal government. In 2001, when I joined NRC, we were focused on the learning marketplace and working with a national project to create a shared network of learning resources. In 2004, I coined the term e-learning 2.0 to represent how learning interacted with social media to form this web of connection. In 2005, that was the development of the learning networks, or connectivist theory of learning. Also in 2005, working on open educational resources, because in order to share, resources must be shareable. In 2008, as I mentioned, I began working with George Siemens to develop the MOOC. 2010, we ran an internal project at National Research Council called PLEARN, Personal Learning Environments and Resource Networks. And today, as I mentioned, we're working on the learning and performance support systems. We can see this approach in what Badr Assalah calls Pedagogy 2.0. It's again the same theory, but from a different perspective. And you can see how he's coming at this from a different point of view, but it's the same idea. He has personalization, participation, and productivity. And these are the things he calls the 3 Ps of Pedagogy 2.0. But you can see how the same underlying elements are there. And that's why, when I say, here's a framework, here's a way of representing the theory, I never mean this is the framework or this is the way of representing the theory. Anything that we talked about can be looked at from different perspectives, from different points of view. Just ignore the bells. That's my clock in the background. Sorry about that. So the model that we've been working on over the years is based on the classic model of the personal learning environment. The diagram at left was created by Scott Wilson. The diagram at right was created by Tim Hand. You can see the same basic principle, and there are dozens and dozens and dozens of drawings like this, or diagrams like this across the internet. At the center of the diagram is the person. So Scott says future VLE, but really what we mean is the person at the center. Similarly, at the center, we have on Tim's diagram the holistic learner. And then connected to that person are the various resources. 43 Things, which is a to-do list. Flickr, which is photographs. LearnChat, which is a chat system. An LMS, content repository, etc. The idea is the person's at the center and connected to many different resources, including other people, including other institutions. So all of these play a role. And the idea here is what we've done is we've created a single node with connections. And you can see I'm drawing my connections in a very shaky hand. And that's one part of the network, right? But then there are other nodes with their own sets of connections. And by focusing on the individual person, we are gradually building up a network of connections from one person to the next person to the next person. And the idea here is the one person has a perspective which they share with the next person, which they share with the next person. And so you have multiple perspectives being, as we say, propagated across this network. And this propagation and this sharing of perspectives changes and shapes the network. And that's how learning happens, through these changes and shaping of the network. So this approach is generally known as the personal learning environment. This is a generic concept. It does not yet refer to a specific thing. There will never be a single application which is the personal learning network, because there are different parts to it, right? There's the part that the learner has. There's the part that an institution might have to share resources with the learner. There's the part that a company might have. There's the part that might be a third party kind of application, like a discussion board or a chat room or a synchronous conference like this. So we have the PLE as the basic concept. We have Web 2.0 supported PLEs, and these are the ways in which the personal learning environment can work with social networks such as Facebook, Twitter, etc. We can have game-based approaches and quantified self, and that's the idea of the personal learning network reaching beyond simple computer courses or computer training and actually begin to reach in to devices that monitor the physical world, such as activities that you undertake or your heartbeat, etc. You have the PLA obviously associated with mobile learning, and ultimately you get the PLE as an assessment tool, replacing static and content-based forms of assessment such as tests or assignments. So where we are focused in the LPSS program is mostly at the technology at the center. And I'll talk about the lpss.me website. That is the technology at the center. That's the thing that we're building right now. It's the thing that an individual user, an individual learner will use to connect to all of these remote things, to their blog, to their social networks, to Twitter, to their portfolio, to whatever. So here's an overall representation of learning and performance support systems as we've designed it at this point. And we have to keep in mind it's a research project, it's a moving target. Already I can see things in this diagram that are wrong, even though I reviewed it yesterday. For example, MATS, which is Multiple Analytic Technologies for Security. That's a bunch of analytics software that we tie into, things like emotion recognition, things like automated translation. Well, now we have another program that we work with called Medical Devices. We've got people from that program bringing in their tools, for example, simulators. There's a neural simulator that shows you how to do neurosurgery and the rest. And so we're bringing in those technologies as well. This here at the center is the center that I was talking about, the tool that the individual learner will use. There's 5 major components, which I'll talk about in the next few slides. We connect with external projects. These are commercial and non-commercial partners that we're working with. For example, other parts of government, for example, other governments, or for example, commercial vendors. We work with data that's out there in the world, everything from sensors from your physical body to data from Statistics Canada to whatever you can think of. We tie in with external applications. This includes learning management systems, it includes content repositories, simulations, and any other external application that you can think of. So that's the overall model. We launched this overall model back, well, it's the beginning of October. It's now being hosted at lpss.me. You can go there and request an invitation. Right now, this is pretty basic still. It's early days for us still. So you won't see a whole lot, but you will see an end-to-end functioning application where you can define the competencies that you're looking for. You can define the resource feeds that connect you to third-party resources or to your social network. You can define your cloud storage system, and then you can have the system take all of that and recommend what you should be reading right now. The recommendations are a bit hit and miss, but the idea is that we have that structure there in place. We still need to add the social component. That's next. That'll be available for our March rollout, which will be the next major version of this. We're doing a slow rollout of capacities over the next 18 months as we build out the system, as we connect it to more and more external devices, as we develop partnerships and capacity building projects. So here's a look at it. This is the competency screen. As you can see, we've gone for a fairly simple design because we're fairly simple people. But you can browse your competencies, you can add new competencies. We've got a mechanism whereby you can import sets of competency definitions. And part of our program, and a really interesting part of the program, is called ACDR, which will actually look at the performance of experts and define by itself the competencies that those experts use. Because one of the most difficult and most time-consuming tasks in a competency-oriented system is the identification and definition of competencies. But if you have a system that can do that for you automatically, you're ahead of the game. Now again, we're not building a platform. We're not building a single thing that everybody comes into and connects. So it's not another Facebook, it's not another Twitter, it's nothing like that. It's not another learning management system. We're not recreating Moodle or anything like that, because again, we want to underline that this model, this approach to pedagogy is based on connecting interconnected objects. So we're building a connector of resources and services. There's the individual thing at the center that the learner uses, but the functionality that this thing has is largely derived from the different connections it has with other resources and other services. So these are the 5 things that were in that box at the center. These are the core elements of the personal learning environment as we see them. So these are the core pieces that we're working on. We call these core technology development projects. We have a separate project and separate staff assigned to each one of these. So first is the Learning Services Network and Marketplace, then the one I mentioned, Automated Skills Development and Recognition. Then we also have what we call Personal Learning Record, also a Personal Learning Assistant, and finally Learning as a Cloud Service. And I should mention all of these are brought together with a common set of protocols and data representation formats that we call Common Framework. I know it's not an imaginative name, but it's a good name. So here we have these core projects represented in a different way. Personal Learning Record is at the center. And then the Resource Repository Network, which connects us to things like SCORM, reports, manuals, email, social networks, and the rest. Personal Cloud helps us manage our local storage and our network and cloud storage, and manages portable storage and devices so that we synchronize the information that we have so it's available where we need it. This is important because Personal Learning Assistant is the tool that as we say, projects learning into different locations. This idea that online learning is something you sit in front of a screen and do is a very short-term phase. And we need to be thinking about online learning as something that is available to you when you're out there in the world doing whatever it is you do out there in the world. This means that the PLA project needs to be able to project the capacities into computers, into mobile devices, into other applications, into environments like simulations, conferencing systems, mentoring systems, into objects like your car and your refrigerator and your microwave, a fishing rod, a tennis racket, into your workplace in the form of electronic performance support systems, and so on. ACDR, as I mentioned, is the analytics. It's building competency frameworks. It's employing machine learning and deep learning to do pattern recognition and cluster recognition. You'll find, if you examine the way we've built LPSS, is that the underlying structure of LPSS is also an instance of the connectivist theory. We've built underlying LPSS a graph representation of the learning environment in which a person finds themselves, and then ACDR can do learning, machine learning on that graph. Using the graph, using the machine learning, we're emulating not only the theory but also the kind of learning we expect the person to be doing themselves. A person in their own mind has a graph representation. A person in their own mind has to do things like deep learning. In other words, they need to be able to detect and identify clusters and patterns for themselves. ACDR helps them with this. ACDR learns about the world in the same way that a human learns about the world. So let me talk about these in a bit more detail. Beginning with resource repository network, what we're looking at here is an open marketplace of both free and non-free educational goods and services. This is a big change from the way things operate today. The existing learning management systems, at least some of them, are looking at being the sole or the proprietary repository of certain types of content. This is especially the case if the learning management system is a publisher repository, where they're not going to be very interested in providing free content. But what we're looking at by creating a distributed network of learning resources, we're looking at what might be called EdNet neutrality. That is to say, the learning provider does not provide privileged access to one type of learning resource over another. It's up to the individual to determine for themselves what type of learning resource that they will use in order to further their own learning. And they have their own tools and their own systems and their own network to support them as they make these decisions. So here's the resource repository network, as I mentioned, the different types of content. So it has to help people manage and discover a list of sources and resources. We do this in a manner similar to the way RSS functions today. In fact, we use RSS in addition to a number of other specifications. And basically, it gives a person a way to manage a whole bunch of different resource feeds. It maintains the person's authentication and credentials. This is important in order to access proprietary repositories or to access workplace repositories or share nets or shared directories, SharePoint, things like that. It needs to support multiple application programming interfaces and metadata standards. And the major task that it performs is to gather, analyze, and sort, and especially filter resources or metadata to, in essence, create a custom learning library for an individual person. Remember, each individual using LPSS has their own instance of a resource repository network, which means each person using an LPSS has what amounts to a personal library. Except we should not call it a library, because this is not just a list of static sources like books and magazines and courses and things. It also includes events, it includes places, laboratories, facilities, it includes people who can help them with a quick question, or people who can act as mentors. It connects to groups and activities, anything out there that's relevant to the person who is learning. Personal Cloud basically manages cloud data, and the key here is synchronizing this. We know that we can't put all of a person's learning data into every single environment that they're going to be in. So the idea is that we need a mechanism to put the right data into the right place at the right time. So our personal cloud project is intended to do this. The way it works is that instead of trying to store everything in one place, it takes advantage of the many cloud data storage services that are available. For example, for Flickr, we can use, or for photos, we can use Flickr. For video, we can use YouTube. For documents, we can use Google Docs or Google Drive. For other documents, we can use Dropbox. For other things, we can use Cubby. There's a whole range of individual storage systems that are available. There's even something called OwnCloud, which I mention here specifically because this is open source software that allows you to create your own cloud data storage on your own network hard drive that you can store in your living room. And I have one just over there. So the personal cloud, like I say, it helps you manage this list of personal, local, and remote storage systems, which means security, encryption, because this stuff has to be secure, authentication, credentials, both local and personal storage, as well as remote storage. And key, it needs to manage and synchronize this data so it's available at the right place at the right time. The personal learning system, as I said, is the projection of learning services into multiple platforms. And the idea here is that not just computers, but all kinds of devices. Here we have a post-mix cocktail shaker. This was created by somebody just doing a brainstorming exercise at Online Educa Berlin. But the idea here is that as this person is just doodling on their pad, that pad should be connected to their learning services. They should be able to save this idea into their own system and share it or do whatever with it later on. The personal learning personal learning assistant does a number of things. For one thing, it collects contextual information for the system so that your LPSS, your personal LPSS, knows where you are, or at the very least knows what context you're in. Because if you're out in the wilderness working at an oil pump, you need one set of information. If you're in a trigonometry classroom, you need a different set of information. And if you're in a French restaurant, you need a different set of information. So your personal learning assistant needs to be aware of the environment so it can tell LPSS what information it's going to need. In the ideal world, and this is a target that we're shooting for, the PLA should have access to your event calendar so that it knows tomorrow you will be out in the wilderness in front of an oil pump. And so it should know tonight to preload all of your oil pump resources onto your mobile device so you'll have them when you need them. The personal learning assistant also is used to display resources in various formats. We've got basic resource display available now in LPSS. We're looking at launching them using Learning Technologies Interoperability, which is an IMS standard for launching different kinds of e-learning applications. We'll display them in various formats, HTML obviously, PDF, SCORM packages so that the resource can communicate with the LPSS. In the Plurn project, we looked at support for the display of resources, something that we called scaffolding. And as well, we want to project LPSS capacity into external software and services. Finally, we want to connect to real learning and workplace environments. This is the simulation system that I talked about here. This is the NRC laboratory in Boucherville, and this is a person, you can see she's using these optical glasses here. She's doing 3D neurosurgery using actual real neurosurgeons tools that you can see down here. And these tools are interesting because they're not just the same weight and heft of real tools. When she uses them, they actually resist the way neural tissue would resist when she uses them. So this is the competency recognition and development part of it, where we import or create competency definitions. In other words, we learn how to recognize competency when we see it. This is used to analyze interactions for skills and learning gaps, which will help people develop their own learning plans. And then these plans will be used to provide resource or service recommendations. Analytics in our system acts as a service. We do analytics differently. We don't take everybody's data and put it into one big database the way Facebook does or Google does. Remember, each person has their own individual LPSS. And so what we have to do with analytics is connect to each of these individually and obtain whatever data these individual people are willing to share. Personal privacy and security of data is essential to learning and performance support systems. Finally, the personal learning record is that data. It's the data owned by the person. It's shared only with permission of the individual learner. This, again, is a really difference in approach from traditional learning and indeed traditional social network applications. In our approach, each person owns their own data. They own their own productions. Whatever they create, whatever credentials they have, they own those. So the personal learning record in this way can collect a full record of interactions with all resources, all external systems. A learning management system can collect many records, but only from one service. We collect records from many services about one person, and the way we're able to do that is to be sure that this data is secure and private to the individual. This is supported with a data exchange format called XAPI. We also collect and support the presentation of the person's personal portfolio, that is to say, any artifacts, videos, text, diagrams, whatever they've created as part of their learning. It's a mechanism for displaying certifications, credentials, for example, badges, and in such a way that if a person presents a certificate, it can be authenticated from a third-party certification agency. So there are various PLR projects underway already out there in the world the Manchester PLA project, Roll, Known, Learning Locker, Mahara. These are all different approaches to this same question of how do you maintain a personal learning record, and we want to work with these services rather than in competition with them in order to support a person's ability to create their own personal learning record, again, in multiple formats and multiple ways. We have various implementation projects that move us from MOOC to personal learning. We've worked with a number of partners, varying from the Arab League to the Organisation Internationale de la Francophonie, to the Government of Canada, to commercial enterprises across Canada and around the world. Our implementation projects are designed to give us actual feedback from the work that we're doing. We're using real users, real people in real learning environments to develop feedback for each of the programs, because learning is about practice and reflection. We're developing LPSS iteratively. We'll build a little bit, find out what people think. Build a little bit, find out what people think. So we're just about to summarize the session here. We're almost done. This is important because technology is not just a tool. It's not just the thing that makes us learn. It represents an extension of our perceptions. It represents an extension of our capacities. It helps us see the world in different ways. It helps us communicate with each other in different ways. The kind of learner we become literally depends on the kind of learning technology we choose. And what we're trying to do with our approach to learning is to provide an alternative to the kind of learning where everything is centralized, everything is controlled, everything is managed. We are stressing personal learning, personal empowerment, personal freedom, interactivity, networking, and cooperation. So that's the basic presentation, and I would be very happy to take any comments or questions that you may have. Okay, so the question was, is there a concern about the ease of access to information, making it more difficult to internalize information? I think that's a reasonable question, but I don't agree with the hypothesis that it's the difficulty of accessing information that promotes internalization. I would argue that it's the use of the information that promotes internalization. I remember a phone number not because it was really hard for me to find the phone number. I remember the phone number because I call it a lot. And if I can always find the information, if I still have to actually type the number into the phone, it's that use of the information that causes me to remember it. So I think that as long as we have a system that promotes use, that will have the kind of system that promotes the internalization of important things. Having said that, also, I think internalization is overestimated. Internalization is a handy function for a human to have, but that doesn't make it inherently good in all circumstances. I try to internalize only those things I really need. Phone numbers are not one of them. Most things are not one of them. And again, it's the things I really need are the things I use a lot. But even some of the things that I use a lot, I don't necessarily internalize because that information is not valuable to me. The things that are really valuable to me, are my experiences, my interactions, and those are the kinds of things I try to internalize rather. That last bit was a bit badly phrased, but I think you get the sense of what I mean. Yeah, sure, not a problem. So the question is how we assess competencies in the system. there's a certain level of technical detail that I'm not going to be able to get into because it has to do with machine learning. And first of all, some of that proprietary to the project, but more significantly, I don't understand it. And we've got some AI experts working on this. But I get the concept, and the general concept is as follows. First of all, we need to define a competency. Then we need to recognize the competency. So right now, the way we define competencies is we predefine them in different competency hierarchies. It's a very awkward, structured, and probably inaccurate representation of the skills that people need. So what we want to do, and what we're actually working on doing, is we collect all the artifacts of an expert's interaction with their community, and as much as possible, their interactions with their work environment, including any tools that they use, etc. We bring these in and we store them in a large graph database. And what we're doing by that is creating, if you will, a graph representation of everything that they do. That's a lot of data. It's a horrible mess, and in that state, it's pretty meaningless. Think of a million XAPI statements, for example. An XAPI statement is a simple statement in the form of subject, verb, and object. Frank poked the tissue, whatever. Obviously, we'll probably need a better vocabulary than that. One of our projects, sub-projects, is an extension of the XAPI vocabulary. As well, we're following the development of XAPI 2.0 very closely. But the main point here is we collect all of this data about an expert's performance. Then we take that, it's represented as a graph, and we run machine learning algorithms on that graph. And what we're trying to do here is what's called cluster detection. And so what we're looking for are patterns that are inherent in the data. Now, these patterns might not be obvious because the data to us looks like, well, it looks like static, right? It looks like random noise. But running deep learning algorithms on this data, we can find patterns or clusters in the data. These clusters may represent competency points. So one of the ways that we identify these as competency points is we have a separate algorithm that assigns names to the clusters. So by first identifying the cluster, then assigning a name to the cluster, that allows an actual human to look at that and say, well, that's a competency, as opposed to, well, I don't know what it's opposed to, but a thing that's not a competency. And the idea is, from this analysis, we create a model of this person's performance that we basically call a competency graph. We're looking at the performance of not just one expert, but multiple experts. And so if you have multiple people who are expert organic chemists, say, the clusters where their data overlaps, that's the things that they have in common that distinguishes them as organic chemists as opposed to, gymnasts, which will exhibit a different set of traits. So that gives us a competency profile for a particular domain. Now, note there is human intervention here, right? We've picked the people that we think are experts in a domain. So we've kind of predefined the domain. And there's probably also human recognition involved in identifying those clusters that are actually competences rather than coincidentally associated traits. Like it might be that organic chemists also really like coffee, but liking coffee isn't really associated, probably not anyways, with being a successful organic chemist. We would not put it into the curriculum anyways. So that, in a very loose nutshell, like so sloppy, I'm sorry, is how we create the competency. Then we apply the same algorithms to a person who is not a recognized expert. And that allows us to identify the differences between their graph and the expert graph, their competency points and the expert competency points. And those differences identify the learning that they need to do in order to become an expert. So once we've identified the learning, we've identified the competencies that they need to develop. These competencies are in turn associated with certain resources. The simplest association is string matching. It's a horrible association, but you get the idea, right? If we can name the competency, then we find any resources with that name in it. But we're looking at more advanced association than that. But basically, almost standard recommender systems to associate the resource with the competency. That, in a very loose, sloppy nutshell, in my inexpert description of many elements of this, is how we do the competency part. Thank you very much. It's been a real pleasure to be able to talk with all of you. Thank you so much.